As a second example, we look at a 2 kilogram mass excuse me, with some unknown force F of t, or some force F of t which is a function of time, and we might not know the specifics of the force, but we somehow know that the average force is 3,000 newtons. And of course, calculus gives us means of determining average forces given a force function, and even with pre-calculus knowledge, even the knowledge of basic graphs, if the force function is linear or somehow simple enough, we can always find the average force. Okay, so we have an average force of 3,000 newtons for a time interval of 0.008 seconds, and we're to solve this using analysis of motion and then using impulse momentum. Analysis of motion is very straightforward. The average force being 3,000 newtons, the average acceleration will be average force divided by mass, or 3,000 newtons divided by 2 kilograms, 1,500 meters per second squared, from which it follows that our change in velocity, equal to the product of the rate of change of velocity and time, is 1,500 meters per second squared times 0.008 seconds, or 12 meters per second. From the impulse momentum theorem, we find that the impulse is average force F bar times delta t, which is again the 3,000 newtons multiplied by the 0.008 seconds, and that gives us 24 kilogram meters per second. Again, using the analysis of units, it tells us that Newton seconds is the same as kilogram meters per second. Now, the mass is constant, so that m delta v is the change in momentum, and that equals the impulse, so that delta v is the impulse divided by the mass, which is 24 kilogram meters per second divided by 2 kilograms, or 12 meters per second.